Hi students, welcome to Vedantu NEET English. I am Diksha Ma'am, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to all of you or not. Everybody in the chat box, am I clearly visible and audible to you? Yes, everybody? So let us start with the class if you all are ready for the class, right? So guys, in the first lecture, what we did, we talked about general E0 potential, how to calculate reduction in uh, E0 cell. That means standard electrode potential, standard reduction potential that we talked about in the first lecture, right? Now, we are going to till which time class, ma'am? Hello, Ramya. Yes. See, class will be, I think, 1.5 hour. I think till 10:30 maybe. Maximum till 10:30 the class will be there. Right? By that time we'll be able to cover this. Right? Okay. Yes, everybody. So, let's talk and let's start doing it. Right? Let's start with the Nernst equation. Right? So now let's see how many of you did the homework for the last part, that is future IITian, Lal Haru, then Sangita. These are the three students who did their homework. That's very, very good. Huh? Very good to all the three students who did their homework. And why the energy is so low? Right? Let the energy be high in the chat box. Okay? Now, students, what was the homework? Zinc can be coated or iron to produce galvanized iron, but the reverse is possible. Is it because of zinc is lighter than iron, zinc is lower than iron? So what you guys have answered is D, D and D. Is it D the correct answer? Let's see. Zinc has higher negative electrode potential than iron. That is true, right? But reverse is not true. See, we know that zinc can be coated or iron, right? We can coat zinc on iron. To protect rusting of iron, we can coat zinc, right? Why we can coat zinc? Because zinc has higher negative electrode potential than iron. That is the reason we can coat zinc, but we cannot coat iron on zinc. That is not possible, right? Because iron will not be able to protect the zinc coating, right? It will itself get rusted, right? So that is the reason answer is D is the correct answer. Next, let us see. Next question is the reduction potential of zinc is minus 0.76 and for reduction potential of iron is this much. So we can clearly see that reduction potential of zinc, right, the negative electrode potential is actually higher than that, right? So that is the reason. Next is SOP is equals to what? SOP standard oxidation potential is what? Is it minus of SHE? No. Is it minus of standard electrode potential? Yes. Standard electrode potential is nothing but reduction potential. So answer is going to be B is the correct answer. So all of you answered it correctly, right? First answer is D and second answer is B is the correct answer. Now let's talk about Nernst equation, everybody. Okay, let's talk about Nernst equation, guys. How many of you are ready for Nernst equation? This particular lecture, right? You will see one or two questions from this. I'm not talking chapter. I am saying lecture. This lecture that we are going to see. You are for sure going to see one or two, maybe three questions can be there from this particular lecture. It's that important, right? Every single formula that we are going to cover is important here, right? I'm going to firstly teach you the formula, then application of the formula. Then we are going to see how to apply the formula with the help of NEET previous year questions. Okay? Yes, everyone, let's see this. First is, let's talk about Nernst equation. Yes, everybody, be interactive in the chat box, right? So, what is Nernst equation? Nernst equation is to calculate the E cell value. E cell is nothing but E naught cell minus RT by NF natural log of QC. Where what exactly are these values, right? So E naught cell is standard reduction potential. or you can say standard electrode potential that we have discussed already how to calculate this. We know that the value of E naught cell is going to be equals to E naught of cathode minus E naught of anode, and we are talking about the reduction potential of both the things. What is the N value? N is the number of electrons lost or gained. In this redox reaction that will happen here in this case, what is the number of electrons lost or gained? What about R? R is universal gas constant. Can you tell me what shall be the value of universal gas constant here? Anybody in the chat box, what is going to be the value? See, universal gas constant has so many values. R can be equals to 0.0821. It can be equals to 8.314. It can be equals to 2. Now, always remember, when we are going to use a value of gas constant, if there is pressure or volume involved, then we will use 0.0821. Can you see any volume or pressure here? No, right? If you see that there is some energy involved, we are talking about joules, we are talking about kilojoules and joules, right? Then we will use this, that is 8.314. So here we know that we are not talking about any volume or pressure, and sorry, we are not talking about any volume. So when there is some solution, let's say in solution chapter, we use 0.0821. But here we are talking about electrode potential, right? That is a kind of energy, right? So that's why we are going to use 8.314, and which is equals to 25 by 3. So in simple language, you can put 25 by 3. You can put it down on the calculator. What is 25 by 3? That is 8.314. Okay. Yes, everybody. So now what about 2? When 2 is used? If energies are given in calories, then we use 2. But in this particular case, we will use 8.314 only, right? Now, what do you mean by this F? Anybody in the chat box, what do you mean by this F? F is nothing but 1 Faraday, that is approximate value is 96500 coulombs, right? R, we have talked about temperature can variate. N is number of electron loss gain. E naught we have talked about. Faraday we have talked about. Now what is this QC? Anybody in the chat box, what is this QC? Anybody? What do you mean by this QC? See, QC is nothing but that is reaction quotient. This we have studied in, this guys we have studied in equilibrium chapter. Chemical equilibrium, we have studied reaction quotient, that is QC, right? At equilibrium, QC is equals to Kc, right? But generally, what is the formula of QC? QC is equals to product by reactant, concentration of product divided by reactant, okay? Don't worry, I'm going to tell you everything in detail only, how to write this Nernst equation for every single thing. Don't worry about that, right? Okay, so this is how it is. Now, this is your Nernst equation. This is Nernst equation, right? Now, we know that Faraday is 96500. This gas constant value is also fixed. And we need to convert natural log into log base 10 because we know the values of log base 10. So what we will do here, we will just solve it directly for E cell in terms of log base 10 will be 2.303 RT by NF natural log of QC. That is the value for when you convert log base natural log into log base 10. Okay, so when you convert natural log to log base 10, it is multiplied by 2.303, right? Now, another formula, when you put down the value of this whole thing, when you put the value of 2.303 Faraday, R and temperature, that is the standard temperature, when you put down all the values here, the formula that we will use maximum, that is coming out to be E cell is equals to E naught cell minus 0.059 divided by n log of QC. And this is the final formula that we are going to use. Okay, this is the final formula that we are going to use. Don't worry, Sai, after this you will find it very easy, right? Understood? E cell is equals to E naught cell minus 0.059 n log of QC. That is the final formula that we are going to use. Okay, right, everybody? Now, I know that firstly, in this particular case, learning the formula is another thing and apply the formula is entirely a different thing, right? So, just by learning this formula, you won't be able to do questions in the exam. You have to understand how to apply this formula in the exam, okay? So, let's learn how to apply this formula with the help of an example. But before that, remember one thing, that concentration of solids. So now guys, see one thing here, that reaction quotient, if they give you in terms of concentration, it will be product concentration by reactant concentration. If they give you gases, if there are all our gases here, then QC will be pressure of product divided by pressure of reactant. Okay. If they have given you gases, then QC will be product pressure divided by reactant pressure raised to power stoichiometry. And if they have given QC as like liquids or solids, then we will use concentration here. So mostly we will use concentration only, right? Now guys, I know that still there is a confusion between this. Don't worry, I'll do that, right? Don't worry. When we'll solve the questions, we will easily be able to understand how to put all the values, right? Just have patience while understanding this topic, right? Concentration of solid and liquid components is always 1, right? And for gases components, concentration and pressure is equals to that we will use, right? Concentration is pressure only, right? Now, I know that this particular thing you are not able to understand. And what do you mean by this? Let's understand this with the help of an example. The example is this. Okay, this is the example. Now, this question you have here, whenever you have a representation, firstly you need to write the reaction here. Okay, so if you see, I told you in the first lecture that this is A and this is C always. This is anode and this is cathode always. So if this is the anode side, this is the cathode side, and what we are doing here, nickel is getting converted to Ni2 positive, and here Ag positive is being converted to Ag. This to this and this to this. This is what is happening in this full-fledged reaction, right? So I can easily write it like this, right? So from the representation, firstly you should know that always this side is anode, this side is cathode. So if I write it individually, can I say that what is happening at anode? At anode, nickel is getting converted to nickel 2 positive. We know that at anode there is loss of electrons, right? So nickel is getting converted to nickel 2 positive. What do you mean by that? That means that this nickel is actually oxidation number 0 to plus 2 oxidation number is increasing. That means 0 to 2 means 2 electrons it is going to lose here. Okay, so we'll write 2 electrons. At cathode, what is happening, guys? Anybody? Cathode Ag is getting converted to Ag positive is getting converted to Ag. Okay, Ag positive is getting converted to Ag. Now tell me one thing. At cathode, what you do? At cathode, what you do, guys? At cathode, we gain the electron or we lose the electron? We gain the electron or lose the electron? We gain the electron, right? So here it is going to gain the electron. If you see this here, how many electron it is gaining? 1 to 0 means it is going to gain 1 electron, right? See, change is this is 1, this is 0. So that means 1 electron it is going to gain, the change is 1, right? So 1 electron it is going to gain, right? Now, if you see, number of electron lost and gained always has to be equal. So if this is 2, this also should be equals to 2. So what we will do, we'll just multiply it with 2. Right? Now, when you add this equation, the overall it will become is this will be 2 and this will be 2. This is the actual overall equation, right? And by writing this equation only, you will be able to understand number of electron gained and lost is 2. So n is going to have value 2, right? N is going to have value 2, right? Okay. Now, can we start writing the Nernst equation here? E cell equals to E naught cell. I'm just writing the Nernst equation here. E naught cell will do the questions where we'll also calculate E naught cell. Firstly, from this particular example, just understand how to write Nernst equation. Okay. So, E cell is equals to E naught cell. For that, tell me what is E naught cell. Firstly, tell me what is E naught cell. E naught cell is cathode minus anode. Cathode is this value, right? That means here you will write about silver and here you will write about nickel. So it is silver minus nickel, cathode minus anode, cathode minus anode. And we are going to write the reduction potential. Reduction potential means it is going to be decrease in oxidation number, right? So here it is going from +1 to 0, it is decreasing. Here it is going from 0 to +2. This is increasing. So we need to write the reduction potential, right? So we will make the opposite here, that is E naught of nickel to positive to nickel, and this is Ag positive to Ag. While writing the reduction potentials, here the number should always decrease, right? Now, if you see this here, the number is decreasing here. As simple fact, what we will do here, this is E naught. Now, let's write the E cell. E cell is going to be E naught cell minus 0.059 divided by n log of QC, right? Let's write this E naught value, you will solve it from here. What is the value of, guys, what is the value of n? Can I say n value is 2? Yes. What is the value of QC? Q in terms of QC means product by reactants. Now, students, this is very important. We know that this is solid, this is aqueous, and this is also solid. Now, it should be, I'm writing it here. Where should I write? I'm writing it here, guys. I'm writing it here, QC value, okay? I'm going to write the value of QC. Where should I write? Okay, I'll just copy paste this and I'll write it here, okay? Now, based on this particular equation, what should be the value of QC, everybody? QC should be equals to product by reactants. Product is what? Product is nickel 2 positive Ag divided by nickel, and there is Ag positive. Now, nickel has no stoichiometry, Ag has stoichiometry 2. Nickel has no stoichiometry here, Ag has stoichiometry 2. It should be the answer. But in reality, I told you this thing here, that concentration of solid or liquid components is going to be 1. Okay. So, here aqueous is given to you. You can take the aqueous solution. Ions, you will take the concentration. But if something is given in liquid, let's say there is water, liquid, this concentration is going to be 1. Okay. So, concentration of pure solids or liquid is going to be 1 always. Right. Okay. That is the reason here we will not write Ag, that is a solid. Here we will not write nickel, that is a solid. So what we will write here, simply Ag positive square. So in reality, we have only the ions, that is this nickel 2 positive divided by this raised to power stoichiometry. That is going to be the value of QC. Right? Okay. Yes, everybody. Is that clear? Right? So that is going to be the value here. So QC is going to be Ni2 positive divided by Ag positive square. Right? So let me know in the chat box if there is any problem regarding this. So I'll just write it here. This is going to be nickel. This is going to be nickel 2 positive. This is going to be Ag positive and square. And this is your final way of writing the Nernst equation here. Okay. If that is clear, then do let me know in the chat box, everybody. Right? Okay, sure, Rehan, as you say, tell me if there is any other advice you have for me. Surely we will follow that. Right? Okay. So now let's talk about represent the cell in which the following reactions take place. Guys, every one of you are sleeping or like sleeping pills you are taking in the class, right? I'll not even say that you have to like respond or interact. You don't want to do it, totally fine. Your choice, right? Your choice. That shows that what amount of respect you have for the teacher, right? So, thank you, Asinath, for responding, right? And everyone, you are awesome, you are great, right? I would never have done that to my teacher, what you are doing to your teachers. And this is not only me, we know that to each teacher you are behaving like this, right? So that's not something to be like actually proud of, right? Just saying, that's rest is totally your choice. Okay, so represent the cell which of the following reaction takes place. So we are going to talk about, right, how to solve the value of E cell here, right? So can we firstly see that the reaction is already given to us? Reaction is Mg solid plus 2Ag positive give rise to Mg2 positive plus 2 of Ag, right? This is what we have here, right? Okay, yes. Now, if you talk about this and this is the concentration, this is the concentration. Tell me Mg and Ag, these are two solids. So the concentration of both of them is going to be unity. Its concentration is unity, its concentration is also unity. Right? Now, let's solve firstly what is the value of E naught cell. What is E naught cell, everybody? E naught cell is E naught cathode minus anode, which is behaving like a cathode. The one which is gaining the electron, right? So we have to write then which one is gaining. This is 0 to plus 2. 0 to plus 2, there is increase in oxidation number. So here you have oxidation. That means it is at anode, right? Here is plus 1 to 0. That means here you have decrease in oxidation number. So that is going to be reduction. That means this is going to be at cathode. Okay, this is plus 1 to 0. This is going to be 0 to plus 2. So according to that, we declared that which is oxidation, which is reduction. Now, we know that E naught cell is equals to E naught cathode. What is cathode, everyone? This is cathode, right? Okay, this one is your cathode. So for cathode, we are going to write silver, right? So this is going to be E naught Ag positive to Ag, because we are writing the reduction potential here. So always here, reduction potential, oxidation number should decrease, right? Minus of E naught. Here oxidation number should increase, right? But we are writing the reduction potential here of oxidation side, because this is E naught cathode minus E naught anode reduction potential. So here we will write Mg2 positive to Mg. Those who are not able to understand this, go through the first lecture that I have taken for this particular chapter, because there I have discussed about and we have solved so many questions based on this thing, right? So go through that lecture, that will help you to understand this thing, right? Now, E naught we can easily solve. This is silver. Where is silver? Have they given us reduction potential? Yes. Number is decreasing 1 to 0. This is 2 to 0. So both are reduction potential. Can I say this is also reduction potential? This is also reduction potential. Here it is 0.8 minus of 2.37, right? 0.8 minus of 2.7, right? Okay, right? Okay. So one student is saying that there is some problem here. So I'll be able to understand this only if other students were able to understand, they can tell me that this is clear or not. Otherwise, if I see one comment saying this, I'll feel that, okay, you guys have not understood, right? Tell me what is the problem you are facing, right? What part you are not able to understand, right? If that is clear, you can also let me know about that, right? Okay. Yes, everybody. Okay. So that's how you solve for E naught. 0.8 plus 2.37, right? So 2.37, that is 0.8. So you can solve it. 8, 9, 10, 11, that is 3.17, right? So answer is 3.17 volt. That is going to be your E naught value, right? E naught cell value is going to be this. Now everyone clear on this part? What is the value of E naught cell? Is that clear, everybody? Is that clear or not? I'm not going to move ahead if you don't tell me if that is clear or not. So, ma'am, stop asking. We will not respond. You, whatever you do, ma'am, doesn't matter, ma'am. Now, we are like this only, ma'am. It doesn't matter to us, ma'am. Right? Is it the kind of attitude that you guys are having right now? What has happened to you? Firstly, tell me. You were never like this. What has happened to you guys? What has happened to you guys? Tell me firstly one thing. Why you guys don't respond? Let's talk about that. Okay, let's talk about what, like, have you gone too lazy to type? Have you gone too lazy to even say if that is clear or not? Because this has never happened, right? I have been teaching on YouTube like for like 4 years now. I've literally never seen students so quiet in the chat box, right? I mean, literally, you guys don't even utter a single word. Right? Do you want us to put recordings for you? Don't you want us to come live and interact with you guys? Right? Very few students actually interact. See what kind of energy you are giving, right? In the, yeah, only Asinath is being, attentive in the class, who is responding. Other students are not even responding when I'm saying something. God bless you guys. Seriously, God bless you. Right? I have given up on you guys. Literally, I can't do anything about it. All I can do is I can do my work. Right? God bless you. And I don't know. It's so funny to see the charts like that. Right? Okay. So E naught, that means I don't need to look into the chat. So now I'll stop even looking into the chats from all the classes, and I'll tell all the teachers here on this channel that these people are not going to respond. Right? Herrick has responded. Shobha has now responded. Shobha has. Asinath is responding. These are the very, very few people talking. Very, very few people. Okay. So, now, beta, one thing I'll tell you. Just understand the situation, okay? I am standing here, right? I have no idea. Are you able to understand this or not? No idea on that, right? All, how will I get to know that if you, everything I'm telling you will get into your head or not? It's for you only that I am asking, right? I am not going to get any benefit if you say yes, ma'am, right? I am not going to post it somewhere. I'll get some I5 awards, Oscar, I will get Nobel Prize, I'll get, if you say yes, ma'am, I'll get Nobel Prize. That Diksha Ma'am, right? She was able to make these students respond in the class. Nobel Prize goes to Diksha Ma'am. Nothing is going to happen like that, okay? No benefit. In fact, my benefit will be if you don't respond. Why? Because I don't have to cater to your doubts. Simple. I'll just have to take a class and go. It doesn't matter you have any doubt or not. Doesn't matter at all. Right? But I'm still here asking you. Right? Is that clear? Why? Because I know that Why you guys lose marks in the exam? Because every single step in the class, teacher is just teaching and students, they have doubt, they don't ask the doubt only, right? So that's why I ask you. But if you don't want to respond, it's totally fine. I will never ask if that is clear. See, I will not be able to detach from you guys, right? You guys have detached from me, but I will not be able to do that, right? So I will surely ask if you that is clear or not, but I'll surely not expect anything from you guys, right? Because I can see very few students are responding, so I'll wait for only these students. Okay? Yes? Okay. Okay, Shobha, chalo, let's move this. E naught cell is E naught cathode minus E naught anode, and both are the reduction potentials. That's why you have to see this plus 1 to 0, this plus 2 to 0. Reduction, that means the oxidation number should always decrease here in both the cases. That's how we will calculate E naught. Now, what is the value of E cell? E cell is going to be E naught cell minus of 0.059 divided by N. Now, can you tell me what is the value of N, everybody? Who will tell me what is the value of N? Who will tell me the value of N here? Right? So, let's see this here. N value, we know that at anode, what is happening? At anode, Mg is being converted to Mg2 positive. At cathode, what is happening? At cathode, Ag positive is being converted to Ag. Right? That means, can I say here 0 to 2, difference of 2. So at anode, electron will be lost, so 2 electrons are there. 1 to 0 plus 1. So that means 1 electron will be added. But number of electron gained and lost should be same. So here you will multiply it by 2, will multiply it by 2, will multiply it by 2. So number of electron lost and gained should be equals to 2. Right? We have to make it equal. Right? So now we can say that N value is going to be 2 here. Log base 10 is product by reactant. Product is Mg2 positive, right? So you can say Mg2 positive divided by reactant, that is Ag positive raised to power 2. That is the stoichiometry. So this is Ag positive raised to power 2. That is the stoichiometry. Now what we are going to do? We are simply going to solve it. So E cell is going to be, this is 3.17, is it? This was coming out to be 3.17. So 3.17 minus 0.059 divided by 2 log of, what is the value of Mg? Mg2 positive is given to be 0.13. Okay. And this Ag is given to be what? Ag is given to be 0.0001. Okay. This is given to be 0.0001. Can you tell me what is this? This is nothing but 10 raised to power minus 4. Okay. So I'll just directly write it as 10 raised to power minus 4 square. Okay. Now, what you have to do is, you just have all the values here, solve all the things here, and you will get your answer here. Right, everybody? Yes. So here what you need to do, just solve this with the help of like simple calculations, right? How do you solve this? Log value, ma'am, it is the most difficult part, right? So it is 0.13 is nothing but 13 into 10 raised to power minus 2. This is 10 raised to power minus 8. This will be converted to, I'll just solve this for you. Okay, I'll solve the value of this log 0.13. Okay, how do you, rest of the calculations you can do easily. Okay, so I know that this can be a difficult part of this particular calculation. Okay, so let's see how to solve this. This will be log of 13 multiplied by 10 raised to power minus 2. This will be 4 into 2, that is 10 raised to power minus 8. This will be log of 13 multiplied by 10 raised to power 6. Okay, that means this will be log of 13 plus log of 10 raised to power 6. Now log of 13, you put the value of log of 13 plus this will be 6. Okay, log 10. What is log base 10 of 10? That is 1. So log of 13 plus 6, that is going to be the answer of all of this. Right, everyone? So that's how you're going to solve it. And to make it easy for you, if they give you something like 13 or so, Ma'am, how to answer log of 13, right? This separately I have made a video of log and anti-log. It was the first session that I took for NEET 2026 aspirant. So go and watch that. That will help you. You can calculate any value of log 11, 12, 13, 14, 15, 16, 17, 18, whatever they ask you, you can easily calculate. Okay, right? Okay, so I can give you a hint about it. What we'll do is log of 13 will be nothing but log of 12 plus log of 14 divided by 2. How to calculate 12 and 14? That you will see in that particular video. Okay. So that's why I firstly made that video, so that I don't have to again and again tell you in every single lecture. Okay. Right, everybody? Now, for this particular lecture, your focus should not be calculation. Your focus should be understanding how to apply it. Right? Calculation, eventually, when you practice, you will be pro in that. Okay. Now find the EMF in the cell in which following reaction takes place at 298 Kelvin. Okay. So this is a reaction that is given to you. This is NEET 2022 question that is there. E naught cell value is already given to you. So E cell is going to be E naught cell minus 0.059. What is the N value? Now I think you are pro at it. Nickel is getting converted to nickel 2 positive. So it is losing 2 electrons. Ag positive is getting converted to Ag. So it is gaining 1 electron. Number of electron gained and lost should be same. So we multiplied it with 2. We can say that value of N is going to be 2. So I'll just put the value 2 here. This will be log base 10 of products by reactants. What is product? That is nickel. So I'll just write it here. Nickel 2 positive divided by Ag positive, and this is square of that. Why? Because here stoichiometry is 2. Right? So once you solve is 10.5, 0.059 divided by 2 log of, what is nickel, guys? What is nickel? Nickel is given to be 10 raised to power minus 3. Okay? 0.001 means 10 raised to power minus 3. 0.00, it is the same. 10 raised to power minus 3. So it will be 10 raised to power minus 3 square. Okay? So that's how you are going to solve this. Now, everything else you can do yourself also. I'll just tell you how to solve this value. This square means this is going to be 10 raised to power minus 3. That means this is going to cancel each other. So answer will be E cell is equals to 1.5. Is it? 10.5. 10.5 minus of 0.059. This is log 10 raised to power 3. Why? Because this is 10 raised to power minus 3. When it will move, the reverse will happen. So it will be 10 raised to power 3. So 10 raised to power 3 is nothing but that is coming out to be 3 log of base 10 into log of base 10. 10 value is equals to 1. Okay. So that's why answer will be this. You can solve this and you will get your answer of E cell here. Okay, everybody. Right? Is that clear? Shall we move ahead? Right? Okay. Yes. Let's do this. Okay. Let's do the next one. The pressure of H2 required. So this is NEET 2016 question. Easily this can be repeated in 2026 as well. It's a good question. Okay. So the pressure of H2 required to make the potential of H2 electrode 0 in pure water is what? Okay. So for this you need to understand this reaction. They are saying that you are doing reduction of H2. Okay. Because what they are asking is pressure of H2 required to make potential of H2 electrode 0 in pure water. If things like this is given to us, we'll take it as reduction. So it will be, if it is written here, I'll solve it from this side. This they have given you that we are using SHE, standard hydrogen electrode, right? Now, if you remember, right, I have also told you about SHE in the previous lecture, okay? Standard hydrogen electrode, which E naught cell is going to be 1, whether it's oxidation or reduction, it's always going to be 1. Now let's calculate, they are asking you to calculate the pressure here. Pressure of H2 required. Okay, so what we will do, we will apply this formula. E cell is equals to E naught cell minus 0.059 divided by 2 log base 10. Base 10 I will not write. On product side, if you remember, I told you whenever you talk about gases, you will write the pressure, right? So this is the gases. So we will write the pressure of H2. Here you have aqueous, so you will write the concentration. So this will be H positive square. Okay? Understood? Now, because this reduction is happening, so we know that this E naught cell reduction is equals to 0. E naught value is 0. E cell is also 0. Right? If you talk about N, number of electron here, that is also going to be 2 because number of electron gained is 2. Pressure of H2 is what they are asking you. In the question, they are asking you pressure of H2. Now, main problem is, ma'am, have they given H positive or not? Okay, let's see this here. See, that's how chapters are interlinked with each other. Okay, so this is a concept from ionic equilibrium that you have. From ionic equilibrium, if you remember, in pure water, right, at 25 degrees Celsius, because we know that according to pressure also it varies, right? At 25 degrees Celsius, H positive multiplied by OH negative is equals to Kw, that is 10 raised to power minus 40. Now, this means that H positive will be equals to 10 raised to power minus 7. This is equals to 10 raised to power minus 7. This is for pure water, right? That's why pH we take 14 at 25 degrees Celsius, right? This is the concept of ionic equilibrium. That means for pure water, H positive concentration is 10 raised to power minus 7. Okay. So can I just write it here? If I write this here, this is going to be, wait a minute. This is going to be 0.059 by N log of pH2. Wait a minute. This is also equals to 0. This is also equals to 0. Wait a minute. Pressure required to make the potential of H2 electrode 0 in this. They have given it to be 0, right? This is given to be 0. This is already 0. So when you solve this, okay. So what is going to happen here? Log of pressure of H2 by H positive concentration square, this whole has to be 0. Okay. So if log of anything is 0, can we say that is equals to 1? For this, you need to know the properties of log. Log of which thing is equals to 0? Log of base 10 of 1 is equals to 0. Okay? This you should know. Log of base 10, if you calculate the log of 1, that value is coming out to be 0. This is the property of log that we have discussed in log and anti-log. Okay? That means this whole value should be equals to 1. That means pressure of H2 is equals to H positive ion concentration square. H positive ion concentration is 10 raised to power minus 7. So it will be 10 raised to power minus 14 is going to be the value here. Right? Yes. So that is coming out to be your pressure here. Okay. So that was a very interesting one, a different question, right? Where you need to know the property of log as well. Log of 1 is 0. So that's why this term inside the log, it is going to be 1. That means pressure of H2 should be equals to H positive concentration square. H positive concentration, we know that that is 10 raised to power minus 7. So it is going to be square of that, that is 10 raised to power minus 14. Atmospheric is your pressure here, right? Okay. Now, that is done. Now let's talk about Nernst equation at equilibrium, right? Are you all ready for that, everybody? Ready for that? Ready for that or not? Let's see this, right? Let's see this here. If you talk about at equilibrium, what happens? Okay, this is E. Always remember, at equilibrium, I'm writing something. At equilibrium, E of cell is equals to 0. E not of cell, I am not saying is equals to 0. The biggest confusion that students have. E of cell is equals to 0. E not of cell we are not talking about. E of cell is equals to 0. Okay. So if I say E of cell is equals to 0, if I put it in the Nernst equation, E cell is equals to E naught cell minus 0.059 divided by n log of QC. Now we know that at equilibrium, QC will be equals to Kc. Okay. Reaction quotient will become equals to equilibrium constant. Okay. So we can say based at equilibrium also they ask you the question. So can we say that this will become Kc? This will become equals to, this will not be 0. Wait a minute. This will become equals to 0. So can I say E naught cell is equals to 0.059 divided by n log of Kc is the formula that you have the relation between E naught cell and Kc. If they gave you E naught cell, they ask you what is the value of equilibrium constant. Then you will calculate it from this one. Okay. We will also do some questions based on this, right? Now, let's talk about Gibbs free enthalpy. Okay, let's talk about Gibbs free enthalpy. Now, at equilibrium, similar way, you have delta G is equals to 0. Delta G naught is not equals to 0. Why delta G is equals to 0? Delta G is not equals to 0, that I will tell you. And QC will become equals to Kc. Okay, QC will become equals to Kc. Now, why I am saying delta G is 0 but delta G naught is not equals to 0? Okay, because delta G is equals to minus NFE cell and delta G naught is equals to minus NFE naught cell. This is the relation that you have. So at equilibrium, if at equilibrium, from this is the relation that you have. Okay, this is the relation that you have. If I say at equilibrium, if E is 0, E cell is 0, that means delta G will be equals to 0. If E naught cell is not equals to 0, that means delta G naught will also be not equals to 0. That's why we have written it here. Because of this particular relation here, that's why how electrode potential is connected to Gibbs free enthalpy. Now, what is this Gibbs free enthalpy that we have discussed in thermodynamics? It is the useful work done, right? Work done that is useful, that is called Gibbs free enthalpy. For now, just this much is needed. Okay, so that is delta G and E. If this becomes equal to 0, this is also 0. So at equilibrium, this is equals to 0, so this will also become equals to 0. This is not equals to 0, so this will also be not equals to 0. Okay, that is how it is. Now, based on this, we'll do one reaction. Okay, based on this, we'll do one more question. Okay, or one more formula that we'll understand. We know that delta G is equals to delta G naught plus RT ln Q. This you must have discussed in equilibrium chapter, right? In equilibrium chapter, you must have discussed this particular equation. Delta G is equals to delta G naught plus RT ln QC. Okay. Now I am saying that delta G is equals to 0, is it? Or I am saying delta G naught is equals to 0. at equilibrium, we know that at equilibrium, delta G is equals to 0. So, can I write this directly that delta G naught be equals to, if this is becoming equals to 0, right? So, can I directly say if this is equals to 0, then this will be minus RT ln of QC. That means delta G naught will be equals to minus 2.303 RT log of QC, right? And this, my friends, is going to be your final equation that you are going to use. Wait a minute, one thing we forgot to write here. We also know that at equilibrium, QC is equals to KC. So here it will be equals to KC. This will be equals to KC. So this is another equation that we are going to talk, that we are going to use. Okay. Total, how many equations we have seen till now? We have seen that we have an equation that is E naught is equals to 0.059 by n log of Kc. If they ask you, they have given you E naught cell and ask you Kc, this is the equation that you need to apply, right? Now, if they have given you the value of E naught and they ask you delta G, that is how you are going to calculate. If they give you the value of delta G naught, they ask you Kc, this is the relation that you have to use. So this relation, and this relation, these are very, very important. Okay, very important 3 formulas for your NEET chemistry. Okay, yes, everybody. Now let's talk about next thing, that is application of feasibility. Now, can you tell me what is feasibility? What is feasibility? What is feasibility? Feasible, possible, right? Is this reaction possible or not? So, feasibility is expressed by spontaneity or non-spontaneity. Now, what are these heavy words you are saying? Okay, let me tell you. So, if I say that, let's say this is delta G, this is E, okay, E naught cell, we can say this is delta G naught, this is the K, okay, this is K. Now, always remember, from this only we can answer, right? From this only we can answer. If E naught cell is positive, right? See, delta G is equals to minus NF E naught cell. So if this is positive, this will be negative. So if this is positive, this will be negative. If this is negative, this will be positive. We have opposite sign, delta G is equals to minus of NF E naught, right? So opposite sign is there. Now, let's talk about Kc. Any formula you can pick, I am picking this formula. If delta G is negative, okay, if I say this is negative, if this is negative, this is negative, this is minus 2.303 RT. Two negatives will make positive, right? So here can I say that log of Kc will be equals to positive, right? So should I write it even from this particular equation? If I say E naught is positive, if this is positive, this whole equation is positive, so this will be positive. So in any case you talk about, whether you take this negative or this positive, we know that log of Kc is coming out to be positive. Here it is opposite. If E naught cell is negative, right, or delta G is positive, if this is positive, this log of Kc will be negative, right? So can I just write it here that log of Kc will be negative here, right? Log of Kc will be negative, right? But they don't ask you log of Kc, they ask you Kc, right? So if you have value, if log of something is coming out to be positive, that means Kc should be greater than 1. Because we know that log of 0 is 1. Okay. Log of 1 is 0. Log of 1 is 0. If you are saying that it should be positive, so it should be greater than 1. If you say that log of something is negative, that means that Kc should be less than 1. Only then it is possible that log of Kc is negative. Okay, this is the property of log that I have written here. Okay, right? Yes, very good first, very good, very good. So, ma'am, now how we will get to know the feasibility of the reaction? Okay, so whether they talk that E naught is positive, or they say delta G is negative, or they say Kc is greater than 1, when you have delta G negative, that simply means it's a spontaneous process. It's a spontaneous process. And whenever we say that delta G here is going to be positive, it's a non-spontaneous process. And spontaneity means feasible. The reaction is feasible. The reaction is possible. The reaction can happen by, again, occur by itself, right? There is no need of pushing that reaction. But non-spontaneity means it is not a feasible reaction, okay? Yes, everybody? Got it? So there is a question based on this particular thing, that is NEET 2016. It says that if E naught for a given reaction has negative value, which of the following gives correct relationship? See, simple is, if E naught is equals to negative, delta G will be positive. So delta G should be positive. This is eliminated, this is eliminated. If delta G is positive, right? Tell me one thing. We know that delta G, and what is the value of E naught, right? So here is a direct relation between delta G and log Kc, right? So if your delta G is minus RT, also you can write ln of Kc. If this is positive, this value should be negative, right? Wait a minute. We are saying E value is negative, right? So this will be positive, right? If this is positive, then log of Kc is going to be this. Yes. Okay. So log of Kc is negative. Log of Kc is negative is possible only in this case. So can I say A is the correct answer? Can I say, guys, A is the correct answer, isn't it? When you have, we have seen this here as well, delta G positive. Okay, delta G positive means Kc will be less than 1. Okay, I think by a mistake, I have marked B as the answer. It will be A answer. Okay, answer will be A is the correct answer. Okay, yes, everybody. Now, that was about feasibility. They can ask you anything. See, I have made this table for you. Out of this, they can ask you anything, right? This is just a sample question that I showed you, right? They can ask you anything. They can say, it's their choice. They can say E naught is negative. They can say delta G, G is positive. They can say Kc is negative, whether that will be a non-spontaneous or spontaneous reaction. These kind of questions, type and way of asking that they can twist, right? They can mold it. But concept is this thing, right? Okay. So you need to have hold over concept. Question you will be automatically able to solve. Right, everybody? Okay. Yes. Let me see. What's the time? What's the time? Okay. It's not that much time. Okay. Now, let's talk about next. The standard EMF of Daniell cell is 1. The maximum electrical work obtained in the Daniell cell. Right? Standard EMF, that means E naught cell is given to you. Delta G naught is equals to minus NF E naught cell. Right? What is the value of N in the Daniell cell? What is a Daniell cell, everyone? We know that at Daniell cell, what you have? Daniell cell, beta, what is Daniell cell? Why it is not working? What is Daniell cell? Zinc and copper electrode you take, right? Number of electron is 1, if you remember that. Okay. Okay. So, number of electron will be 2. Okay. You have taken zinc as an node. copper as cathode, right? If you remember what happens there, zinc will lose and become Zn2 positive plus 2 electrons. Copper will gain electrons and will become Cu. 2 electrons will be there that is involved. So it is going to be delta G naught. So answer is going to be delta G naught. This is the useful work that you have. Mod of this is the useful work that you have. Okay. So answer is going to be N is what? N is 2, Faraday is 96500 and this is 1.1. Solve this and you will get your answer. Okay. Solve this and you will get your answer. Okay. Yes. Okay. Very good. E cell E naught minus 0.059 by log Kc. Very good. Okay. So that is done. Now next question is the standard potential of following. So this is 2024 question. That is, this thing is given to you. Calculate the standard Gibbs energy for the reaction. Okay. So they are asking you to calculate the standard Gibbs free energy. Right, everybody? How do you calculate it? What is given to you? E naught is given to you. The standard E naught value is given to you. How many electrons are gained or lost? Here you have n factor is 2. Here n factor is 2. So number of electron lost or gained will be equals to 2. Right? Directly also you can tell. Right? Delta G naught is equals to minus n. N is 2. F is 96500. And what is the value of E naught? E naught values, here they have given exactly, see, we approximately take it as 96500. If they have specially mentioned that take it as 96487, then I'll take it as 96487. Otherwise, we will take approximate value, that is 96500. Okay. Now, here what we have is 0.32 is the value, and that's how you will calculate the delta G value. Okay. Right? That is the value of delta G. Next question is based on 2019, that is for a cell involving 1 electron. Already telling you 1 electron is involved. So can I say that n factor they have given already 1? N factor means n only. That you will see in redox reaction. So that's why I didn't tell you that it's n factor. Okay, so don't get confused. It is the number of electron lost or gained. Okay, E naught cell is given to you. Equilibrium constant, for this they are asking you. Now you need to find out the value of E naught with equilibrium constant. So it is the simple relation that E naught cell is equals to 0.059 divided by n log of Kc. Right? E naught is given to us, that is 0.59. This is 0.059. This is 2, this is log of Kc. Can you solve this, guys? Yes. Log of Kc will be equals to, or you can just do it on the next page. Log of Kc will be equals to, this will be 2 into 0.59, 2 into 0.59 divided by 0.059, right? So how you will actually cancel this? This is nothing but this is 1000. This is nothing but this is 100. This will cancel. See, this will cancel. That's how you can do it. Okay. So can I say this is coming out to be 200? No, this is coming out to be 20. Right? Okay. Log of Kc, we have solved that. That is coming out to be 20. Rest of the things, do we need to solve it? No. Okay. Right, everybody? Do we need to solve it? No. Right? That's all what you needed to solve, log of Kc. Okay? Log of Kc. Right? Okay? The equilibrium constant they are asking you, that we have already calculated. Right? Okay? So, next is, let's talk about the next one. In an electrochemical cell, this reaction is given to you. They are asking you what thing, let's see that. Okay? Yes, everybody? Tell me if till now it is clear or not. Right? Shall I move ahead? Now, next is in a electrochemical cell, you have, see, this is actually kind of relation that they are asking you to write. Okay. So this is, they are saying that this is the reaction that you have, right? The EMF of this Daniel cell is E1. For this particular situation, it is E1. If you are changing the concentration of ZnSO4 to 1 and CuSO4 to 0.01, then the EMF is E2. They are asking you to find out the relation here. So simply we'll divide it into two pages. One is where E cell is equals to E naught cell. See, E naught cell will be same, okay? Because the cell is same, cathode is same, anode is same, so E naught cell will be same, right? This is minus, this is 0.059. See, N factor is also same because number of electron gain and lost is also same. Concentration is changing, nothing else is changing, right? So this is log of, if you see, this is a question of 2017, okay? So product by reactant. Now ma'am, what is product? You know, when these things you already know directly, do I ma'am need to write down again the reaction? No. Why? This is A, this is C, that I told you in representation, right? Now, anode means oxidation, cathode means reduction, and you know what is QC? Simple trick is that it is also oxidation by reduction. It is also called product by reactant. Okay, this will help you. This will save your time in the exam. Okay, so oxidation by reduction. That means firstly you will write zinc, then you will write copper. Okay, so this will be Zn 2 positive, copper 2 positive. Okay, now you have two values here. If E1, if you are saying it is E1, this E naught cell I am writing, E1 is when you have log of, see, we know that for Daniel cell it is 1.1, here it is 2, we know that, but still I am not writing it. Why? It will eventually cancel out. Okay, so we don't need to write it. So this is log, what is zinc here? Zinc is 0.01, this is 1. Okay, so you'll write 10 raised to power minus 2, this is by 1. Okay, what about this one? E2 is E naught cell minus of 0.059 divided by N log of, in the second case for E2, CuSO4 is 0.01 and Zn is 1. Zn is 1 now. CuSO4 is 0.01, that means 10 raised to power minus 2. Can I write this as E naught cell minus 0.59 divided by N? This is log of 10 raised to power 2. Can we solve these two values here? Can I write this as E1? Can I write this as E1 is equals to E naught cell minus of 0.059 divided by N. This will be minus of 2, right? This will be log base 10, that is 1. Okay, that is the answer. So you can directly write it as minus will be 1. So this will be multiplied by 2. We know that N factor is also 2. So I'll just write down the value 2, it will cancel. So E1 is going to be E naught cell plus 0.059. First equation. Second equation is, let's solve the value of E2 here. E2 is going to be equals to, E2 is E cell, I am writing E naught cell minus of 0.059, N factor is 2, right? Now this 2 will go in front and this will be 2 and 2, this will cancel. E2 is going to be E naught cell minus of 0.059. This is the second equation. This is the first equation, right? Now guys, you have one equation. Tell me which is greater. Can't you tell it from here? Here you are adding something. Here you are subtracting the same value. From E naught, that is 1.1. You're subtracting 0.059. You're adding 0.059. So can I say E1 is greater than E2? Can I say that E1 is greater than E2? Okay, Subhya, I'll definitely do that. Okay, we will definitely do. Firstly, my focus is structure of atom, then periodic classification, then chemical bonding in class 11th. Then I'll do redox reactions and all. Okay, so that is the flow of the lectures. Okay, so answer is going to be B is the correct answer. That is E1 is greater than E2. Right? Now, last topic of today's class, and 90% you will get your question from this one, right? See, what was the trend? Okay, 6-7 years back they used to ask questions dependent upon based on Nernst equation. Then they moved towards equilibrium. At equilibrium, what is the relation between delta G and equilibrium constant? What is the relation between E naught and equilibrium constant? The trend shifted to that side. Now, very slightly it is moving towards conservation of energy, right? So, what exactly is conservation of Gibbs free energy? Let's talk about that. Okay. So, guys, for this you need to remember that if, let's say, from this kind of flow chart, this will be very easy for you to understand. Okay. So, let's say, and I am always going to write the reduction potentials here. Okay. I'll always talk about reduction potentials. Oxidation is obviously opposite of that, right? So you can say reduction means decrease. So E is getting converted to A positive. No. Reduction potentials, no. So A2 positive is getting converted to A positive. Then it is getting converted to A. I am doing reduction. Okay. Let's see. Here E2 positive to E, let's say E naught potential, right? E potential you can say, let's say this is E1. Here it is E2. Number of electron gained is N1. Number of electron gained is N2. Now this is directly from A2 positive to A. Here it is E3 and number of electron is N3. Okay. Firstly, tell me, are you able to understand this chart here? Right? Are you able to understand this chart here? This is some 2 positive, this is 0. I am saying that reduction is happening here. I'm just giving you one example, okay? We'll also see that how to solve these kind of questions, okay? So this is the reduction, this is overall reduction. Now, in these cases, we can't say that E3 is not equals to E1 plus E2 because electrode potential is not conserved. You can't say this E1 plus E2 is equals to E3. No. But we can definitely say that delta G3 is equals to delta G1 plus delta G2. Energy is Gibbs free enthalpy is conserved here. Okay? Energy we can say is conserved. Now, who will tell me that how do we write energy? We know that delta G is equals to minus NFE cell. Okay? So, can I just write it here? This is minus N for delta G3. This is N3. F Faraday's constant. This is E3. Is equals to minus N1 F and E1. This is minus or plus of minus N2 Faraday and E2. I just wrote down this definition here, right? This formula I put here. Now minus will cancel Faraday will cancel and it will become, the answer will be in the end will be N3 E3 is equals to N2 N1 E1 plus N2 E2. This is what you are going to write here. Tell me, students, if that is clear or not. N3 E3 is equals to N1 E1 plus N2 E2. That is the overall answer that you have here. Is that clear, guys? Is that clear? Everybody in the chat box, is that clear? Now we are going to use this particular equation to answer any question here, right? So this is your JEE Mains 2023 question. Now, ma'am, why you are teaching us JEE Main question? Because see, same pattern will be repeated in NEET, right? They will take hint from JEE only, right? Conducting agency is same, right? Moreover, right, concept, syllabus, everything is same, right? Level is also approximately same only, right? So that's why JEE previous year question also you should do for your NEET 2026, right? Now let's see this. In an electrochemical reaction of lead at standard temperature, if this and this is given, they are asking you what is the value of X, right? In JEE, there are integer based questions, so that's why they have asked in integer format. For you, they will ask you this in the form of options, right? A, B, C, D, which of the following is correct, right? Let's solve this, okay? For that, apply the flow chart. Now, what we write here is reduction. The oxidation number is always decreasing here. 2 to 1, 1 to 0. So here also it should decrease. Minimum oxidation number is PB, maximum oxidation number is 4 positive, write it maximum. After that, this is PB2 positive, write PB2 positive. After that, write PB. Okay. Maximum oxidation number to minimum. Always write the reduction potential. No matter if they give you oxidation potential, also write reduction potential. You need to fix it, okay? Otherwise, you will do silly mistakes in the exam. Fix reduction potential in your head, right? Now we know that they are saying, is this reduction potential? 2 to 1 oxidation number is decreasing. Reduction potential is given. That means this is reduction potential. 4 to 0 reduction potential is given. 0 to 4, they are asking you oxidation potential. But we are very smart. We will calculate reduction potential. Then we know that oxidation potential is minus of reduction potential, right? So we will focus on reduction potential only. So from 2 to 0, that means this to this, they are saying it is M. E naught value is M. Number of electrons that is gained here is 2. Okay. Here number of electron from 4 to 2 is 2. And what is the E naught value from 4 to 2? Array, wait a minute. Here what they are doing is, they have given you this value. They have given you this value 4 to 0. 4 to 0. 4 to 0. This value they have given to be N. And here reduction potential is given. I'll write N. Number of electrons involved is 4 to 0. 4 electrons are involved. Right? Number of electrons are 4. Here number of electrons will be 2. We have no idea what is the value that, we have no idea what is this. Okay. So here they have given that this value is coming out to be this. Okay. Now let's not get confused. Okay. We'll simply solve the value of E naught here. So I'll take it as Y. Okay. I'm considering this as Y. I am assuming this as Y. Okay. Now students, by applying this particular method, can I say that can I say simply this plus this is equals to this? That means 2y is equals to 2m plus 4n. Can I say that? Isn't it the formula? N3E3 is equals to E1N1 plus E2N2. This is, what is this, guys? This is E naught. This is E naught. This is E naught. So E naught multiplied by electrons, E naught multiplied by electrons, E naught multiplied by electrons. This is E3, this is E2, this is E1. Right? So if I divide it by 2, can I get Y is equals to M plus 2N? Wait a minute. This is not the answer. Wait a minute. My mistake, guys. This is E3, okay? So it will be 4n is equals to, this is E1, this is E2. So this will be 2y plus 2n, okay? So it is going to be, when you divide it by 2, this is going to be 2n equals to y plus n. So y will be equals to, we can say y will be equals to 2n minus n. Is it the correct answer that you are getting? Y will be equals to, thank you so much, Isubia. I really hope so all of you actually understand this. We all are actually sacrificing our personal life for you guys, right? We know that you have school in the morning. That's why we are keeping the classes in the night, right? Who will teach you at 8 or 9 or 10 p.m., right? We guys are teaching you, right? So it's not like we don't have families, right? We have families. We also want to spend time with our families, right? When everyone is watching some Netflix series at our age, what people are doing, right? They don't have any exam. We don't have any exam, right? So it takes, like, that's why I ask you that respond something, right? So all we want is your response, so that we can also get to know that if we are putting efforts, then you appreciate that, right? So that one comment from you guys makes our day, that okay, someone is appreciating, someone is actually realizing the efforts, right? But when you guys don't even talk, we feel that you have taken us for granted, right? So that is the main issue, right? So firstly, tell me if that is clear. Y is equals to 2n minus m. Can I compare this? Oh, wait a minute, guys. Am I doing it wrong? Yes. This Y is the reduction potential, right? They have asked you the oxidation potential. Oxidation potential is equals to minus of reduction potential. It is minus of Y. That is m minus 2n. So when you compare, when you comparing this with m minus xn, x will come out to be 2. So answer will be 2. Okay. So answer will be 2, and these kind of questions, see, nothing big, but chances of mistake are highest here. First thing, here you can do mistake. By putting this formula, you can do mistake. Second, here they are asking you oxidation potential, but here you will be able to calculate reduction. Keep the arrow in mind. This is moving to this side. That means the reduction is going. This also reduction is going. No matter, even if they have given me the oxidation, for example, they gave me that N is the oxidation potential, then I would have taken minus N as the reduction potential, right? So always remember arrow going from this to this side, and oxidation, you will start from maximum oxidation to minimum oxidation states. Okay, that's how you're going to do it, right? Everybody, is that clear? So that was the last question of today. If you have any problem, then you can let me know in the chat box, right? And in the comment section as well, for those who are watching it on the recorded version, because some students love to see YouTube and lectures at 2x speed. So for them, I'll be speaking at right, and it'll be, that's why, you know, they feel that okay, less time is consumed in that, and this also I have covered. So if you're watching this at 2x speed, slow it down and solve this question by yourself and write it down in the comment section. Okay, write it down in the comment section, guys. Okay, everybody. So that's it for today, and this is the Diksha Ma'am signing off. But before that, this is our Vedantu NEET English channel, Telegram channel. Scan this and you will be landed to our page where all the PDF notes, everything will be provided there, right? And homework and comment of that homework is necessary, right? If you actually appreciate the efforts that your team, NEET English team, is putting, right? So wait a minute. And here, students, we have which thing? First is, wait a minute, let me just show you. So guys, if you see this over here, right, you will get this DNA batch 2026. What exactly is this batch, right? So in this batch, guys, we have our live classes, right? In detail, lectures are taken. There is a class teacher, dedicated class teacher in the class. You can ask your doubts to the class teacher and to your teachers as well. Quizzes are there. Leaderboards are there in the class, right? Today I started solution chapter in the class, right? In the batch, we have started solution chapter, right? So regular classes are being taken, and if you see, there are proper mock tests taken after every 15 days. Like students have their mock test next Sunday. So this Monday, they will be provided already with the test. What is the topics for the test that they will have? Whatever we have covered in those 15 days, we'll take the test, right? After that, students, DPPs are provided, Tattva modules are provided, Vedantu modules for your practice. Not only this, test series are also provided to you. This is just at 4999, right? You will see the plans also here. If you talk about whatever I asked you, that these are the things that will be provided. Oh, okay. Whatever I asked you, that these are the things that will be provided, that is at 4999, right? And if you want quick revision cards, these are the quick revision cards. These are the Vedantu quick revision cards, okay? Very interesting for physics, chemistry and bio, both, all of them it will be provided. Can you see this? These are the cards that will be provided, right? This is for chemistry, and there is a very small book for reactions as well. Book means not a book, big book, this much small book is there for the, I'll just someday I'll show you the book also, right? So all of these things are there, right? For physics and bio also you have short notes, just like this, right? That are your quick revision cards, right? So these quick revision cards plus All India Test Series hard copy will be delivered at your home at 7999 if you want to deliver it at your home. And if you want Tattva books also, not the soft copy version, here soft copy version will be provided. If you want books to be delivered, like proper hard books, right? That means just like you have this register, right? So a set of, I think, around 24 books will be provided to you. I feel, yes, 8 books, 4 books for 11th class chemistry, 4 books for 12th class chemistry is there, right? Because see, everything is there, right? So set of 24 books are there in total. So that's why the charges are 10,999. So it's not like we will provide you a small booklet. No, proper 24 books, right? Where 8 will be of chemistry, I think 8 will be of bio, and 8 will be of physics, right? For chemistry, 4 is for, someday I'll also show you Tattva modules. If you want that next class, I'll download the Tattva modules and I'll show you what exactly is that. So that if I'm asking you that is the best book, if I'm guaranteeing that why I have this guarantee, right? Because daily in the batch, we solve questions from the Tattva modules, right? I give students the homework from the Tattva modules, right? So if you do Tattva modules, if you're in the mock test, if you're solving the DPPs and test series as well, nothing else you need. That is more than sufficient that is needed for your exam, right? So that is my advice to you. That is at 10,999. I would advise you to purchase this one because QR cards, pocket friendly QR cards will be available. All India Test Series hard copy will be provided to you, delivered at your home. You will have 20, like approximate 24 books that will be delivered at your home. And you don't have to, use that much, you don't have to give that much screen time. Your eyes also need some rest, okay? That rest, if you at least when you practice, stay away from computer, right? Because your classes will be there on online, right? So for practice, less screen time will be there, and you can relax your eyes also for that, right? Okay, strain will be less basically, right? So that is my advice. And I'll see you all in the batch, that is DNA batch. DNA week, doctor NEET aspirant, right? And we know that becoming a doctor is in your DNA, but for that you have to get enrolled into the batch, right? Okay then, bye-bye students. Good night. Take care. See you all in the next class. Bye-bye.